Great, and good luck.
Cool. All right. So first off, welcome all of you. Welcome everybody online. Thank you to Integrate for sponsoring our Lunch and Learn today. Integrate is awesome. They hire some awesome people. Do we have audio? Are we good? Are we up? Potentially don't have audio, so I got to stall for a minute. Cool. Well, I'm going to pretend that I have audio out here because I think y'all can hear me. How's everybody doing? It's good to see some faces. I haven't seen you all. Hey, Shirley, how you doing?
I'm doing well.
Good. Glad to hear it. It's been quite a while, yeah. I feel that way just like every time I go out. I'm like, I see somebody, I'm like, wow, I haven't seen you in actually almost 2 years because of the pandemic. So we're up, we're good. Audio, sweet. All right. So today you get a delightfully alliterative talk that I have called Turkeytime Typescript Tips. And I practiced hard to be able to say it that fast. A Thanksgiving-themed TypeScript tutorial. I hope that we have a good time. Hope we learn some stuff. And the first thing I want to talk about is that I've started using TypeScript pretty exclusively since about earlier this year. I've made the switch from like some stuff I kind of dabble with to pretty much everything I build is going to be TypeScript over JavaScript. Background on me, my name is Michael Panik. I am a tech lead at Alloy. We are a local software development house. We work for clients all over the country of all different scales, and we build software for hire, an agency type. And so with that, we end up building products that are sort of, they kind of last a long time. They kind of have to last forever, and maybe they're built once. And then there's integration phases where we're adding on to them later, but it's not like a product company where you're constantly iterating. It's like very sporadic. We build it this year and 2 years later, they have some big additions they want, so we implement a new phase. With that, it becomes pretty hard to maintain these projects outside of, we do a simple maintenance on most of them where we're just keeping things up to date, keeping them running, small changes. But if you don't build things right from the get-go, it can be really hard to extend them later. It can be really difficult to kind of get in and make the big changes they want at a later date. So TypeScript makes a lot of sense in agency world. And then if you are building a product and you are working on the same code base every day, you want it to be extensible, flexible, all of those things, and you want to really build that way from the get-go. So I think TypeScript is kind of fantastic. I was super against it for a long time. I was like, that's a whole lot of extra work. And so my first thankful thought here, some of these alliteration things are going to be really stretching it. So just bear with me. Let's do the best. TypeScript really doesn't take that much time to implement or build with. I mean, most tools that you use, whether it's Next.js, Gatsby, Express, if you're doing anything with serverless, whatever, there's kind of out-of-the-box boilerplates to start using TypeScript immediately. The tooling is there. It's not the world of yore where you have to set up all this crazy Babel configs to compile your TypeScript. Like, that's all gone. Most of it's already kind of done for you. And it doesn't take a lot of time to build with. I find that really kind of once you get into the riff of it, you start thinking about things in a different way to where you are building just as, within a couple of months, maybe a couple of weeks with it, you're building just as fast as before, as just inferring your types. And you really don't have to do a whole lot of processing. It's not slowing you down. It does help you avoid a ton of the small errors, bugs, typos, that crap that you deal with every single day, where you spend 2 hours chasing down one thing and you just realize, oh, this is an object, it should be a string. I did that earlier actually because I didn't type it. I was doing type inference, and then I realized, it's like, wow, if I had just said, hey, this is an object, it would have caught it immediately. So if you haven't worked with TypeScript a lot, you get all these nice features within your IDE, especially if you're using VS Code. It's fantastic. It'll find all the little things and tell you, hey, idiot, this is wrong, this doesn't match. And then, like I said, it makes, anytime you're working with multiple devs, it becomes super manageable when you're working in TypeScript because there's less question of, all right, so-and-so built this function and it takes some arguments. I don't really know what the arguments are, so I gotta like command click in and I gotta read his code, figure out what they meant by this, what the arguments are and whatever. Is going to show you that kind of out of the box. And you get some of that with IntelliSense. If you're in VS Code or anything that uses IntelliSense, you can kind of see some of that, but this is very immediate. It gives you a lot of feedback very quickly. Super nice. One thing that's interesting to know, especially if you're new to TypeScript, maybe even if you've been doing this a while, is that TypeScript only does this at build time and while you are developing. So once it actually compiles it down, those types are gone forever. They don't actually exist. It's not like C# or Java or any other type language. Those types don't exist once it's compiled. It's really just a tool to help you build better and faster and all of those things. So now, obviously, if it does that at compile time, it will prevent those type mismatches. It'll prevent things like that. But it's really for your benefit. It doesn't necessarily speed up the code that you write. Like, it's not necessarily going to make it more performant, anything like that, because most of the TypeScript stuff completely goes away once you actually compile it. I just thought that was interesting. I learned that not too long ago, and I didn't know if that was common knowledge that I didn't know, and I don't know, but I figured I'd throw it out there. So we're going to get into a little bit of actual TypeScript stuff, but first I wanted to just ask who in here, because last time I asked this and most hands went up, who here has worked with TypeScript, works with TypeScript regularly, has some experience? Anybody? Cool. Okay. All right. So we also have some people who are like, this is new to me. This is different. Let me just give the background then that TypeScript is essentially, it is just JavaScript. It's just like whatever the current spec is. I guess it'd be like ES7 or ES next. That's all I type in my config, so I don't know what she actually is. It's one of the ES. It's the latest iteration of JavaScript with static types. Types are just saying that every variable, every argument, every whatever has a certain type that it has to be, right? It can be multiple types. We'll look at some of that. It can be variations on those types, but it has to have a certain type. So basically, if I say argument A needs to be a string because I'm going to do some things like a split, I'm going to split it into an array in this function. Well, string is the only primitive that has the split method on it. So it has to be a string. So I tell the function, okay, argument 1 is the type string. And now if I'm writing my code and call this function, I put a number in argument 1, I don't know, JavaScript's weird. So it might have normally accepted that, but now it's going to say, no, this has to be a string, make it a string, and it will throw errors. And so I find that I can write like honestly, I could write a few hundred lines of code and never even run anything. Write a few hundred lines of code, scaffold up a bunch of stuff, save it, run it, and it usually works because all those little bugs of, oh crap, all the little things you don't even realize how often you screw up, your IDE has already caught it, underlined it, warned you about it, told you, hey, idiot, fix this. So that's why I love it. It's been a big game changer for me. I've started doing it on, mainly I'm working in React and serverless JS APIs. So putting TypeScript on top of both of those has been really game changing, especially for the speed factor. I feel like we're building better code a whole lot faster. So today, main things that we want to jump into, I want to talk about the way, I say the proper way, and that's really, really arrogant. I shouldn't have even put that in there. I feel bad even saying the word proper because this is the way I think about TypeScript. And of course, the way I think about everything is right. You can ask my wife. Everything I think is perfectly right. So I just want to talk about like the way that I think it's best to approach it and typing as a whole, how you should kind of approach it. We're going to talk about some more advanced TypeScript. I actually skewed a little more beginner, and now seeing who's here, I'm actually glad that I did because I started to go into some like really dense stuff that I've been trying to wrap my own head around lately. Glad I didn't. We'll get into just some like intermediate stuff that I think will help. And then we'll have a big old Q&A session, maybe some answers. I'll do my best. So let's see. First thing that I would say is to type early and type often. I feel like maybe it's a Java thing or a C# world thing where a lot of people try to write a bunch of code, make it work, and then they go back and type everything. And to me, that is 1,000% wrong. Like objectively, that's a wrong way to do it because again, these types are not doing anything when they're compiled. They're doing nothing once they're compiled. It's only to help you build. So I always try to think about the data first and scaffold out what I need based on that. And I'll show you some examples of that in a second. But if you take this data first approach, what points of data are coming in, what points of data am I getting out, and you type those things out, and you determine how you're going to structure your data first, your code is generally going to be better, and you're going to write it a lot faster. You're going to get to the point faster, which is not always the point. I got to break and say that a lot of people, I think, harp on like, oh, you're going to write so much more code so much faster. And if you're learning it, that's not always the point, but your goal should be to get better, more proficient, to write better code faster. That's like our end goal as developers, is to write better code every time, more consistently and faster. Because if you do that, you will have a more successful career, and you'll probably enjoy it. It shouldn't take you like, an hour to write a string reversal 2 years into your career. Like, you should pretty much know how to do this kind of thing. So that's just a little diatribe. Types kind of force you to think data first if you approach them type first. If you write your types out, then you are already thinking about the data. Boom, then you're implementing it. So my approach is scaffold things out, which is basically just a lot of comments to do, whatever, blah, blah, blah. Think through the problem. Think through what I have just scaffolded out, especially with the types. Think about contingencies. Okay, maybe I'll need this, maybe I'll need that. Fix it, and then actually start implementing everything, and actually start writing code and building. So let's jump over here. Actually, I'm going to create a new, and I did all these in advance, and also have them down here on my paper. Let's just look at some really basic stuff, especially because we got pretty new. Let's take a question. It seems like so big on my screen. I already have it like blown up here, and I'll do that too. Is that better? Cool. All right, great. We're going to set this as Typescript so we can get some highlighting going on. The first thing that we'll look at, is just a very basic type. And since this is all going to be Thanksgiving themed, my last one was Halloween themed. This one's Thanksgiving themed. If I come back next month, it'll be nice and Christmas themed, or holidays themed. Might just throw every holiday in there together. So I wanted to do a meal because I love Thanksgiving, because I love to eat. Big boy, like to eat. And so we're going to define a type that is a meal. And when you use kind of data-driven, data-first thought process, ask yourself, what data points will I need? What kind of makes up, and we're getting into a little bit of like object-oriented theory here, but what makes up a meal? Open to the room, open question. What makes up a meal? Courses, actually, I hadn't even thought of that. Maybe high class, you're thinking about courses. No, we'll just list them out and then we'll talk about it. What else? Oh my gosh, okay, we're getting really, really intense. Protein and calories, and I just thought like straight up dishes. But actually, there's, yeah, we gotta have our turkey, we gotta have our mashed potatoes, we gotta have sweet potato casserole, pie.
Yeah, I guess.
But see, that the courses is really good, right? Because courses is going to be like an array, right? We understand the basics here, so it's going to be like multiple courses. I'm gonna put a pin in those, and I'm gonna stick with courses. This actually makes it really easy. So it's going to be an array, and right now it can just be any type of array. The array can have anything in it. With TypeScript, we can further define that the courses property of this meal type is a certain type of array. Every item in the array has to be a certain type, which is going to be a course, right? And so then we have to define what a course is. And this is the way I like to work, because here again, we're just sort of working backwards through the problem. Okay, now we know we have a course. Well, courses are going to have dishes, right? And a dishes property is going to probably be an array of dishes. So then we have type dish, and then we can start defining things like the protein and calories. Maybe makes more sense to do that on the individual dish, right? Yeah, so these are going to be numbers. See, I'm just doing that type. It's going to be number. Type is number. Nice thing in TypeScript, you don't have to define integer or float. You have an all-encompassing number property that you can use, which is sweet. It's giving me an error for dish. Oh, yeah, because I've got stuff open in other files, so we'll ignore that. Basically, as I have it defined here, done like that. And then you saw I have also like ingredients. Let's say like ingredients. You might even continue to break it down. So like, ingredient could be its own type that then contains what? I mean, ingredients are going to have like the amount, whatever. I'm not going to get that granular with it, but that's just kind of the idea. I'm actually just going to make this a string array for now. So just type out the ingredients. And then also dishes would have like a type, right? So there's desserts, there's entrees, there's all kinds of things. So we might just say string, right? And there you go. That's a pretty basic way of kind of thinking about your types, right? So now we have a meal that has a list of courses, and it has to, this is a required property. It has to have courses. Anywhere we implement or use meal, if we were to say, you know, we're passing in like, call it function eat, and then eat takes a meal, and it has a type of meal, it's going to get really mad at me if I were to then call eat and give it an object that didn't have the property courses, right? It's actually throwing that error now because it's going to say that this is not assignable because dishes is missing, but it's required in meal. Why does it say that? I've probably, because I've got that defined somewhere. Let me do this. There we go. All right, cool. Now we get all the benefit. Don't overwrite your own types. Now it should complain, yes, that courses is missing, right? Because we've said you have to have courses. But as long as we give it courses, it should work. Oops. Nope, it won't. It's still going to throw an error because let's expect this. Let's give it a string. It's going to throw an error because it says, oh, it's got to be an array of courses. So we make it an array, but it's still not an array of courses. This is not a course. It forces you, once you scaffold it out, it forces you to build. And that's how, like I say, you can kind of write a whole lot of code without running it and kind of pretty well know that it's going to work or not. You can make any of these optional. So let's say that like, this is the holidays, calories don't count at Christmas. So adding that question mark just means that I can now implement dish and I don't have to include calories. I'll have to include protein amount, I have to include ingredients, has to be an array, and type has to be a string, but I don't have to include calories. We can make any of them optional we want. Here we have ingredients is an array of strings. But maybe it's just one ingredient. Maybe like one of your dishes is super lazy, like, I don't know, cranberry sauce. And it comes in a can, and it's literally one dish, canned cranberries. So you can also say it is potentially also, it's string or, just it's a string array or just a string. And we're going to look at some more of that stuff here in a minute. The other thing I like is that you can define options where it has to fit one of these options. So for dish type, we know there's basically entrees. And so now we can say that type, right now, type has to equal entrees. Can't equal anything else. That's totally pointless. But we can use that same little union to say it could be an entree or a side or a dessert. And now if we implement dish, it's going to require us that it has a property called type that equals a string with the value of either entrees or side or dessert. That's your 5-minute crash course in TypeScript and how to approach typing. It's really fast. Before I move into some of these other concepts, what questions do we have?
So that's basically a num, right? That's the proper way to enumerate string.
You can actually do natively. You can do enum dish type. I guess we'd probably do. We can do that here. Nope, it's no equal. Some things have equals, some things don't. And then we would do like entree. Be string of entree, and then I think that's so wrong. I don't remember how to do this. I don't use enums that much, if I'm being very honest. But then I think type could then be dish type, and then it's going to require you, it's going to require you it to be one of those things. But here you're using proper, so then your type would have to not be a string. It would have to be dish type dot entree or whatever and require that. So you can use enums. I like this a little bit better for just specific string values, especially in React. This becomes really really easy when you're passing like, let's say you have an alignment property, it needs to be left, right, up or down or something like that. You can force it to require or to be up, right, left, or down. Now, if you're worried about mistyping and typing LETF instead of left, then yeah, enums will kind of prevent you. But again, because you're in TypeScript land, it will sort of prevent you from doing that from the get-go. It'll throw an error and say, this is not equal to left, right, up, down. And you change it, you figure it out. So I think that there's definitely places to use enums, but this is a more simple, this is called just a union, I guess, a union operator.
If you have a large list, where you would lay me on the same.
Yeah. Yeah. Oh, yeah. If it was like 30 of these things and I'm going to be using them in multiple places, it's like error types or something. Yeah, making an enum, and we're going from there. Cool. What other questions? Sweet. I'm the best teacher in the world. Great. Let's talk about interfaces. I'm going to switch back over and we'll look at some interfaces. Interfaces are like types. They have more functionality. You can do more with them. They're more feature rich. You can extend them. You can implement them. And in my opinion, you stick with types until you really need an interface. Types feel more rudimentary. They feel more basic. It's more like a primitive relative to like a type. The only word I can think of now I know is type. But it just feels more rudimentary. It feels more basic and simple. And I basically want to start with the simplest and then build up. So start with a type, and then the second you need to kind of implement some things, or if you need to extend things, that's when I'd probably go for interfaces. So let's look at that really quick. We'll do, so we'll actually stick on this little thing here. We're using types. So rather than dish being its own kind of base type, we can make it an interface. I'm going to put an I in front of anything that's an interface just for my own use. And then we can take and say that maybe, entrees, like you're going to have some different properties. They're going to have different properties in dessert. So we have an interface I entree dish, right? And now this is going to have, let's say, a type that is fixed to entree. So we don't have to declare it necessarily. It just has the type of entree, and we know that. But even more usefully, like an entree, if we had flavor palette or something, your entree is almost never going to be sweet. Like it's always going to be savory. So you can have some properties there. Other things, this example's falling apart because I can't really think of what data points you have about an entree specifically, but who knows? Or maybe just like a meat, and the meat can be turkey, or maybe even like poultry, or beef, or seafood, or whatever, So you have separate properties. But the problem is this interface is totally separate from this one. But an entree dish is still going to have the properties of a dish. So what we may want to do is that entree dish extends iDish, and because they are both interfaces, we can now do that. We can extend it, and so now, anytime you use the I entree dish, you have properties of protein, calories, ingredients, and now meat. And then we can create an interface for dessert, side dishes, whatever. We can sort of extend our type system that way. There's some ways that that you can use this really nicely. It's nothing is quite coming to mind. I know that it's. Give me 1 second. I think it's especially useful. Nope, I've lost my train of thought. What you got?
If you put entree under iDish and have it as a poultry or beef or steak.
Sure.
So I kind of not understanding.
All right. So the whole idea is it's the same thing as a type, right? They're really the same, except you get some like special features. You get like some little bonus things that you can do with an interface, like extending. It can be extended. You can extend other ones. You can also do a couple of other things. And the main idea here, though, is that we want a core dish, like this core idea of a dish, and then we want to be able to extend it to have multiple types that have their own little things that go with them. It's almost like saying, you take all these properties and you take these over here, and now you have something new. It's not what it once was. And an interface should be more abstract. I guess that's what I'm trying to say. The difference is that a type is more thoroughly implemented, and in general, interfaces are more abstract. They're sort of made to be implemented. Some people would probably even tell you that like you should never use, eat. Dish should never like actually implement entree dish. Like that should never be a thing. Sorry, eat, whatever. Like you should never do that. You should actually have a type of entree equals entree dish. I think that's a little extreme, but it really depends on just how you're building. So again, some people would say that you only ever use a type and you sort of construct with abstract interfaces. Interface is always very abstract, but I don't fully agree with that. Yeah.
Would you say that it's an example of all entrees are?
Yeah, exactly. Yeah, that's exactly it. And so because right, all entrees are dishes, we're extending the concept of a dish and making it unique with a meat. We're just saying that it always has a meat. Sorry to the vegans in the room. It's not fair. There we go. All right, just real. Okay. That's for everybody else. You can suck on that. Oh, we're streaming. I can't say that. Whoa. I'll take it back. So does that make sense? I will say that it is a little confusing, sort of the differentiators, and it's something I feel like you just kind of you learn to play by feel. Like you just sort of after a while you kind of get when you need an interface. And like I said, my hard and fast rule is like I use the type, and then if I know that I have a sort of a base type that I want to extend, boom, it becomes an interface, and that's what I use until I don't have to. Other things you get with interfaces. I think we're technically going to look at later, or that might have been one of the things I took out. No, it's still in here. So we'll look at some other ways that becomes helpful here in a little bit. Oh, cool. Yeah, what other questions about any of this? Yeah. Yeah, how lazy are you? Well, that's a very good point. You should be lazy. You're a developer. But like, how lazy are you as a developer? Because yes, I will say that my team probably hates me right now because if I am ever reviewing code and I see any, it's failing immediately because you should never use any. Literally, there are like 5 specific examples of when you should use the any type. Otherwise, it's like, I mean, if you're scaffolding something out and you really don't know how it's coming back, you don't know what's coming down from an API, you just need to put something in there. Maybe. But yeah, any literally means it can be anything, which is just kind of defeats the purpose, right? At that point, why are you even writing a type? Yeah, I would say that like the only times you do that is when I can accept an array of any type because I'm doing something that's just very generic. But at that point, yeah, there's probably something disconnected. You're not thinking through the problem correctly or adequately if you're using the any type. So one example I'm going to do later will actually use an any type, but I'll show you one of those like 5 places where I think it's kind of beneficial. We can get there in a second. Yeah, anything else before we go on? Cool. All right. Talk about conditional types. We've already done this like just a little bit. We saw some of the stuff where we're basically saying it can be this or this, right? And I think technically they've kind of changed what they call a union and what they call conditional. Like Typescript's verbiage has changed around a little bit. If you look up a union type like 4 years ago, it is totally, completely the opposite of what it is now. So that's confusing, and I don't know what everybody calls everything now. I'm calling this conditional, but really it's just a pipe. It's just that or statement that we saw earlier. It's useful when you have variations on the same idea, but you kind of need them all together. I actually have a good implemented example of this we'll work through. But it simplifies the experience and the module implementation a lot of times. If it's just like, it can be this or this, but it has to be one of these two, or one of these three, or whatever it is. So my example that I really liked, even though this is, everybody has their like Thanksgiving traditions if you celebrate Thanksgiving. And this is one in my family that I don't really care about. I was in marching band, and I really hate parades. I've done way too many of them, and I hate them. They're terrible. Don't go to them. Don't support them. It's a blight on society. That's off my soapbox. But Mason Thanksgiving Parade is national treasure, and you can't say anything bad about it ever. So we're gonna build a parade. We're gonna type a parade. We're building, the software that dictates the Macy's parade, and we're gonna build a backdoor that blows the whole parade up. We're gonna do that last and hide it. But for now, we just have a parade object, and a parade has participants. So again, I'm gonna use my little block here, and then we're gonna say that what is a participant? Well, if I started with a type, I'd say like a parade participant has, or why did I choose that word? Has, maybe it's got like a sponsor, most of the things are sponsored. Well, they've all got a position, right? They have a position in the parade. That's going to be a number. What else might a participant have? They're going to have like performers if it's a float. Which would, I'm guessing I always call it a string array. And then you have like, I don't know, like if it's a balloon in the parade, it's got like a character. But I mean, suddenly, a character and a performer, they're not going to exist at the same time, right? Because you have floats or you have balloons. So here again, okay, suddenly there's two very different types of parade participants. We might even, and so I think this is a good opportunity to use an interface, right? That whatever is in common between all of these things, we would make as the abstract base interface, and then we're going to extend it to have, I guess we'll call, what we call maybe like a balloon and a float. Those are two different ideas. So first off, we know that those things will not apply to both, but we know position will. So we're going to change this to an interface. Also, I think I'm going to call it, I'll call it participant. That's fine. And then we're going to create two more interfaces that extend this. We're going to call one float, which gets confusing. Maybe it should be parade float because it is not a floating point number. And it's going to extend I parade participant. Great. Then we're going to do another one that is a parade balloon, and it's going to also extend it. Okay. What do I have here? A parade element is what I originally called it, so that's not good. A float's going to have a sponsor, right? We know that. Everyone is sponsored by Kraft or who knows what, whatever. I don't know what Kraft was what came to mind, but somebody know what the Kraft float normally is? It's like probably like mac and cheese or something. Yeah, I don't know. And they always have performers. If you guys ever watch the show 30 Rock, they always make fun of all the characters on the show having to do the Macy's parade, and like, Jenna's performance, when she always talks about being on the Macy's parade, it cracks me up. So, gotta have performers. A balloon though represents character. My favorite is Snoopy. I'm basic. And then what else I have? I had a number of handlers because there are surprisingly actually real people down there. Who knew? They actually carry those things through the streets. I thought they're just flying. And then some of them are animated, some of them move. So we'll call that just a Boolean. And so now we have two distinct ideas. We have a float and a balloon. And they share some things in common because they're all part of this parade. We might even have a parade band. There's also the ones that perform on the stage. That's a totally different thing. Some of those overlap. So, there's a lot of different ways that this sort of all falls together. And so now we have this option. We can say that participants are either a float or a balloon. They both extend participants, so we can leave that abstracted away. And so we could just do I parade, float, or like we just looked at, I parade participant, right? This is a good, no, I keep using participant. Good grief. There we go, okay. So it could be either one of those. We can also say that if we're going to need an array of participants, because this way right now, participants would be an array of 1. That's not good. Technically, we could like say it's, do like an array interface, and then you put those in there, and like that would actually work. But I think much easier, and especially if we're going to use this union, this intersection of types anywhere else, I'd probably make those a proper type called parade element. This is probably where I'd use parade element equals either one of those, and it's going to complain because that's in another file. And now participants can be an array of parade elements. That is, any of those. It can be a float or a balloon or whatever. So here we've used a base abstract interface. We're extending it with some other types that have, special things that only relate to them. And then we created a type that sort of is the union of all of those together, and we're using it in a parade under participants. Does that make sense? Does that kind of tie all the things we've looked at together a little bit? I thought this was the best example I came up with that was still thematically relevant. I was pretty proud of this. I actually came up with this at 10 o'clock last night and rethought all this. So cool. Glad it worked. Glad it was worth it. What questions right now? Are we getting it? Are we following? Making sense? Cool. Do you guys see how this would, and girls too, I'm sorry, folks. I got to start using folks. That's my good go-to word. Do y'all, or just y'all, yeah. Do y'all see how this would save you a lot of time? If you're implementing these things, if now suddenly we have to create a new parade, and parade has to have these elements, it's going to tell you immediately what you need for each one of these things. If you try to, all right, if you need to build a new parade and you use and implement this type, it's going to tell you immediately exactly what all pieces you need. And you save a lot of time rather than digging through and be like, okay, does a float have handlers? No. Balloons have handlers. Is it a Boolean? Whatever. All that's pretty immediately available when you start implementing it. It'll give you all your nice little IntelliSense stuff.
So
yeah.
Then it makes sense.
Yep, that was me, man, because I cannot express. I hated TypeScript. I was like, this is stupid. Why would you do this? This is a waste of time. And then when you realize that you probably approach your problems pretty data first anyway, this makes a lot of sense. Suddenly, I'm just thinking about the data. I'm not thinking about code and business logic and implementation. I'm just thinking about what data am I dealing with. And if you start there, especially when you're implementing another library, somebody else's TypeScript project, and all those types are there, like you're talking about, holy cow, that'll change your life because there's so much less doc digging and stuff. Like if you're using TypeScript, it's self-documenting. It shows you what you need for these functions, and that's a beautiful thing too. And I'll say this too, we're working on a huge project right now, and I've been a real stickler about not only does everything need to be typed right, but you also use doc. So I use old school JS documentation. And I think the question is, why would you use both? Just a little tip for you guys. If you take and you document everything as well as type it out, you can see those descriptions that you write in line. So suddenly it doesn't just say argument, whatever, argument sponsor is a string. You can say, you document it. Technically, you can do it at the type level, but I could also do it in my function. And I put a little documentation block that says sponsor, string, and then this is the corporate sponsor of the float. So then as I'm typing and I get to this, it'll say, like, you need all these elements. And I hover over sponsor, it will say that little description. I'm like, that's what it was. Because you don't need it right now, the first time you implement it. But again, like 2 years from now, you're re-implementing the same function or class or just, I don't remember what I did yesterday. I really don't remember. It's 2 years ago. So super helpful and kind of forces you to be a little data first, like you said. But doc blocks and TypeScript together are winning combination. Cool. What other questions? How are we doing on time?
You got 19.
I got what?
19 minutes till
90?
19.
Oh, I was like, holy crap. It's like I'm done. What are you talking about? Well, cool. Then I'm gonna do this one last thing where I talk about extracting. So we're just going to actually take what we have here. TypeScript has some built-in interfaces. And the thing I didn't get super into, so we're going to come back to with interfaces, is that they can take arguments in a way, which is really useful. And that's when you really make the jump into like the crazy advanced stuff where you're doing like mapping and really weird stuff with your types that honestly I don't even use that much. I feel like I probably could use it. I'm still learning too. Let's say, for example, that we wanted to extract certain fields from a type. And I'm trying to think if there's a good, I know I used this recently, and probably what I was doing, I think I was taking like the base HTML image element, and I was actually using a different thing that excludes certain fields. I needed an image element, but I needed it to use something that was like React specific and not require like like in React, you can't use class as a property, you have to use class name. And so I think I was like trying to do something more akin to that. So like don't require class or don't take class, only take class name. So you can use certain interfaces and then in those angle brackets, pass it an argument. An example here would be, let's say we only want a type of float performers. It's going to do this automatically because I've already done it in another file. We can use the extract type, and you see it coming up, that it's going to extract from the type T, all those types that are assigned to U. So we know that in our iParade float here that, performers is an array, and it's actually the only thing that is an array. It's actually the only thing that's an array in all of the parade elements. So we might say that float performers, or even how about parade performers, would be better. We're going to extract from parade element, which is going to encompass both of these interfaces, which both implement this one. We're going to extract here's your anything that is an array. Boom. And this is now going to be the only thing that's going to return right now is this list of performers right here. That's the only thing it'll return because we've extracted any arrays from anything that is considered a parade element. And what we have considered a parade element is the float and the balloon. Here's the float, here's the balloon. The only thing that's an array is the performers array. Now, of course, we'd probably want to do like a little more. We could actually say here, I think we could do performers, right? Nope, doesn't like that. It's got to be in quotes. Yeah. So that would actually say, that would just pull the performers out of, again, anything that's in, because again, let's say that we have we can make this make a little more sense. Interface iParade marching band. God bless those poor kids. Extends parade participant. They are a participating unit. And then they have members, right? But we might not call that members because who's to say they're any different than other performers, right? They're all kind of the same. We might even say that a performer is its own type and whatever. But performers is also going to be a string arrays. So now this parade performers would give us, it would be a type of performers that is, a single, that is always a string array. Let's say this was like some kind of performers array, because we have performers here, but this was still just strings. Now this is suddenly the equivalent of, it could be an array of performers or an array of strings, right? Any element in this one array could be a performer or a string because we are extracting everything named performers. Now, we could just as easily, with this example, do any array. It's going to take anything in all of these, because we're going to include that here. So it's going to take anything in these interfaces that is an array and say it can be an array of any of those types. And now that's what performers is. So that's pretty useful. Again, say something like that. You're now implementing your own thing. Maybe your performers have much more data and the other one is just a string, but you've got to be able to get to kind of all of them. This is a good way to do that. Extract anything that's called performers or anything like that. 2 hands.
In this specific example, since you have a string array and performance object array, if you wanted to take a specific performance object array here, would you do be performers or video or coaching?
So, I mean, I would say, if you're just trying to take an array of performers, then there's actually no need here. You would just do, your type parade performers would literally just be performer array. You know what I mean? Be singular, not plural. But yeah, that's all I would do, right? Because then effectively you're doing the same thing. We're not actually extracting data. We're just extracting types and sort of combining them together. So this extract is its own type of interface, and then what we're passing in here is essentially two arguments. What are we extracting from, and then what are we extracting from it? And there's some other ones too that are all built into Typescript, and you can write your own that also take these sort of arguments.
From one of our online viewers, Jennifer Nelson.
Oh, hey, Jennifer.
So she made a point that be sure to use the interfaces, especially with external. This might have been earlier, but with external libraries, just due to simplicity, I guess.
Yeah. If you're writing a library, that's a very good point. If you're writing a library for use for external use, especially, it's probably better, I guess, to use interfaces. You should get the full extensibility. You can also overwrite them. So if you have a library in here that's got an interface called whatever parade float, you can namespace your TypeScript types. I actually don't know how to do that. I'm sure it's just like namespace this, and then ta-da, you're in the namespace. I've never done it. But it's probably really useful if you're writing like an NPM package or something. It'd be very helpful. And then, you can overwrite an interface, and it doesn't overwrite it, it just extends it. So like right now, if I were to say, if I named something else later on, interface I parade marching band, because maybe everything up here, this comes in from library, but then I'm just kind of overriding it myself. I think it's a hacky way to do this. I would see this getting very confusing, but then I could say like school is a string. And so now I haven't overwritten this. I've just effectively extended this interface itself. So I'm saying essentially extends I parade marching band, which I think that will throw an error. But that's all I'm doing there. I'm extending it. And now if I call that, if that's in scope and I use that, it's going to expect a string of school. Or
So when it compiles back to JavaScript, it combines those components?
Well, when it compiles to JavaScript, everything's gone. None of this type stuff matters. But what it would do is if I say, const marching band equals, maybe just a good example here would be useful. So let's say that I take, and I just comment that out. Right now, as long as I give it, and I'm going to say this should implement I parade marching band, and it's going to throw errors. It's going to say, oh, well, you need performers. Okay, yeah, I know I need performers. And that should be an array of performer, which doesn't exist right now. That does. And then we also need a property of position, right? Because it going all the way back to the top, it implements parade participant, which has a position. And so we're going to say they're number one. Cool, that's great. If I write a new interface that's in scope, oh, boom, oh, you need school also, right? Because I have effectively just extended this interface that we're implementing. So then I have to give it school. We'll give it good old Gadsden City High, old alma mater. Perfect. And now it's not going to scream at me anymore because we've implemented everything. But if I remove that, if that wasn't in scope, it's going to say, hey, school property, that does not exist. That's not cool. We can't use that. So again, locking you into all those things. Does that make sense? That's another just nice advantage to interfaces. And why if I was writing a module for external use, I would absolutely want to probably mostly do that. Cool. What other questions? Do we have any more online? Do we have any more in the room? Does everybody feel like they've got? Yeah. Yeah. That's it.
Now looking at the documentation,
Yeah. I mean, that's the thing. It feels so foreign and so weird, but when you realize, oh man, I'm literally just writing JavaScript and I'm telling it what to expect. That's it. You're telling JavaScript what to expect. Hmm. Yeah, I mean, a lot of people gun in as if it's this whole language, and you approach it different. I think you do approach TypeScript a little different, but at its core, you're still just writing JavaScript. You should type everything. You don't even have to. It's not going to scream at you for not having to type. It's not like C# where you get compile failures because it doesn't have a type. It's all a tool. It's just for your own benefit, and then it's going to throw it all out the window when it compiles. So yeah, it's getting in that mindset helps, and then getting in the mindset of it helps you implement your own code, and it really helps you implement other people's code. That's been the biggest selling point for me.
Really helps in the React world where your layers deep and you know what the object is and you're blocking some property.
Yep. Yeah, I do a lot of Gatsby, and so we're taking in these GraphQL queries from working with Sanity right now, which is great. But the data comes back, and I'm like, I have no idea what is all here, what potentially is here. So we're actually working on it right now, trying to figure out a way maybe to have a private package that takes all the types of the Sanity data, where they can apply it in the API side, and I can apply it on my side, and I see all those types right there. I know what properties are available. So I'm not digging into CMS, I'm not digging into their code. I'm just writing. Yeah, very handy. What else? Anybody want my turkey recipe? I mean, yeah, week out, so cool. I think that the only real conclusion I could probably give, we looked at the extract a little bit. So the best probably conclusion I give to all of this is that if you're working in a silo and you're working alone and you're working on your own thing, you probably end up looking at TypeScript and kind of going, I get the point of this. This is stupid. This is all this extra work. But the second there is one other person working with you, and the second you have to update your own code in a year and whatever, you will thank yourself tremendously for kind of building this way. And then also, I don't know what stacks y'all use, but like I said, I know that Next.js, when you create a Next app, you can immediately include TypeScript. Gatsby can immediately include TypeScript. Serverless, Express, fancy stuff, and Vue. I'm sure you can write Vue in Angular. I know you write TypeScript, and who knows what else. Whatever stack you're using, if there's JavaScript involved, there's probably some immediate. Yeah, I haven't touched Svelte yet. I really don't know anything about it. So, but I'm sure that. Do you write? Okay. I hear a lot of those fanboys saying that.
Well, Svelte is different. We'll just say that. But Svelte apparently does support TypeScript. So.
Cool. Yeah, everything does now, and usually pretty out of the box, as you put it.
If anybody wants more food, I did just let the depot know that we have food in here. So
Cool.
some will make them.
If you're hungry, get it down.
Yes.
Yeah. Y'all heard that alarm? That was the free food alarm throughout the depot. So make sure you jump in now. But cool. Thank you guys for being here. I really appreciate everybody coming out. Thanks for I don't know how many of you online. 7. Hey, that's my magic number. I had 7 last time, right? Cool. Thanks to all 7 of you online. If you have questions, I should put my contact info up here. You can email me. It's michael@michael-panik.com. Or just chat me afterwards. And I don't have all the answers, but I got Google, and that's pretty darn close. So just, ask away. Thank you, Mikhail, for, as always, putting these things together, having me, and who knows, maybe I'll be back in December with a nice Christmas-themed something JavaScript related. If you have something you want to know JavaScript-wise, if there's something you want to learn more about.
Maybe you can do something on Svelte.
Okay, well, I would have to learn Svelte really quick, but.
No, we may do something.
Cool, yeah, I love that. Yeah. That's 99% of everything we do as engineers is just taking something from here and putting it over here. I feel like that's all I ever do. What do? I take data from here, put it over here. Sometimes I make it pretty. Usually I just take it from here, put it over here. I get data from here and here, and I put both right here. And then, like all of them. Yeah, that's all you're gonna do. Sorry, don't lose sleep over, I don't know, especially computer science majors. Like, stop losing sleep over all this crap. All you're gonna do is move data around for the rest of your life.
So David Robinette said, the JavaScript beginner, this has been super helpful. When and how to make an interface makes a lot more sense now. Thank you, Michael.
Yeah.
Thank you to integrate your sponsor. And Jennifer also said thank you.
Cool. Well, thank you, Jennifer. Thank you, David. David took my recent LinkedIn advice to heart and built himself. Did you see my post about that?
Sure.
I went on a little diatribe about build yourself a website, and he actually did. So, like, mad props to you, man. If I haven't thoroughly expressed, that's awesome. And good job on the site too. You did a great job. I went out. For any of you guys that aren't friends with me on LinkedIn or follow me, whatever it is on LinkedIn, we're not connected. I went on this whole thing recently about, like, I don't understand juniors, especially people right out of school, right out of boot camps that want jobs and they haven't built anything. It's like, just build something, and the easiest thing in the world for you to build is just build yourself your own website. Like, literally just put something together that shows off that you can build something. But man, so many people don't do that. Just insane. So yeah, and if any of y'all fall in that category, build yourself a little website. It doesn't have to be fancy. Yeah, even better. Yeah. We can't. Yeah, we're getting way off, but yeah, you can kill it if you want to. Bye, everybody.